If this video really helped you, then please help me too. Hello guys, I am a college student now and I suffered from an incident, so at present I can't paying my high college fees. So if you people can help me by donate some money to complete my study, then it will be a great help from you. Hello guys, welcome to our channel Mr. Curious Scientist YouTube. Today I will discuss on the topic computer science and engineering syllabus. In this video you will get every details and don't need to go anywhere. The topic mainly cover all subject details from 1 to 8 semester and subject topic and semester-wise marks distribution and also text and reference books. I will explain the syllabus in 4 different sections, for example topics and chapters and their marks distribution and topics detail-wise explanation and reference book. Now this mechanical engineering B.Tech course will be conducted in 4 years and each year will have 2 semester. 1 now come first year first semester. Theory part Mathematics 1 Programming in C Physics Engineering Mechanics Basic Electrical Engineering. Practical part Programming Lab in C Physics Lab Basic Electrical Engineering Lab. Sessional Engineering Graphics. Now this subject marks distribution will be in 3 different ways, for example lecture given in the classrooms by the professor and notes, and theory part and the practical. 2 now come first year second semester. Theory part subject Mathematics, 2 Object-Oriented Programming Chemistry, Basic Electronics Professional Communication Environmental Science. Practical part Object-Oriented Programming Lab Chemistry Lab Basic Electronics Lab. Sessional Basic Manufacturing Systems Language Lab. Extra academic activity. 3 now come second year third semester. Theory part Engineering Thermodynamics Fluid Mechanics 3 Electrical Machines and Power Electronics Material Science and Engineering Kinematics and Kinetics of Machines Mathematics 3 Practical Fluid Mechanics Lab Electrical Machines and Power Electronics Lab. Sessional Machine Drawing and CAD Manufacturing Practice. 4 now come second year fourth semester. Theory part Machine Dynamics Fluid Dynamics and Hydraulic Machines Basic Manufacturing Processes Mechanics of Solids Engineering Metrology and Measurement Numerical Methods. Practical Machine Kinematics and Dynamics Lab Hydraulic Machines Lab Material Testing Lab. Sessional Business Communication. 5 now come third year fifth semester. Theory Heat Transfer Internal Combustion Engines and Gas Manufacturing Processes and Design Fundamentals of Machine Design Industrial Engineering and Operation Institute Elective I Professional Ethics and Code of Con. Practical Heat Transfer Lab Metrology and Instrumentation Lab Advanced Mechanical Lab. Sessional Machine Design Cognitive Aptitude Test I. 6 now come third year sixth semester. Theory Refrigeration and Air Conditioning Metal Cutting and Cutting Tool The Design of Machine Elements Department Elective I Institute Elective 2 Open Elective I. Practical IC Engines and RAC Lab. Sessional Tool Design Computer Aided Design and Analysis Cognitive Aptitude Test 2 Minor Project. 7 now come fourth year seventh semester. Theory Department Elective 2 Department Elective 3 Department Elective IV Open Elective 2. Practical Computational Technique Practice Lab. Sessional Practical Training Project Part I. 8 now come fourth year 8th semester. Theory Open Elective 3 Department Elective V. Sessional Project Part 2 Seminar General Viva Voce. Next list of Institute Electives. Institute Elective I. Engineering Economics Public Finance International Economics. Institute Elective 2 Organizational Behavior Human Resource Management Entrepreneurship Management Concepts and Practices. Next come list of Department Electives. Department Elective I. Advanced Manufacturing Processes Principles of Turbomachines Mechanical Vibration and Noise Engineering Mechatronics Supply Chain Management. Department Elective 2. Power Plant Engineering Fundamentals of Finite Element Method Metal Forming Processes Total Quality Management Computer Integrated Manufacturing. Department Elective 3. Robotics and Flexible Manufacturing Systems Fluid Power Engineering and Control Advanced Mechanics of Solids Production and Operations Management Mechanics of Composite Materials. Department Elective IV. Automobile Engineering Computational Fluid Dynamics Machine Tools Technology Advanced Operations Research Additive Manufacturing. Department Elective V. Mechanical Measurements and Control Tribology Alternative Fuels and Renewable Energy Machine Maintenance and Condition Monitoring Industrial Safety. Next topic come Applied Sciences Physics. Oscillations and waves. Damped and forced oscillations. Resonance. Sharpness of resonance. Types of waves and wave equation. Interference of light. Analytical treatment of two-source interference. Distribution of energy. Newton's rings. Applications. Diffraction of light. Types of diffraction. Fraunhofer diffraction by single slit. Diffraction grating. Determination of wavelength of light by grating. Laser and optical fiber. Spontaneous and stimulated emission. Population inversion. Pumping. Ruby laser. Applications. Principle of optical fiber. Optical fiber as waveguide. types of optical fiber, acceptance angle, numerical aperture, applications, electromagnetic theory, gradient, divergence and curl, Maxwell's equations in differential and integral form, electromagnetic wave equation in free space, plane wave solutions, transverse nature of electromagnetic waves, quantum mechanics, inadequacy of classical mechanics, de Broglie hypothesis for matter waves, phase velocity and group velocity, Heisenberg's uncertainty principle, wave function and its physical interpretation, Schrödinger's equations, particle in one-dimensional box, potential barrier, tunneling and applications, thermodynamics, laws of thermodynamics, thermodynamic processes, variables, internal energy, enthalpy, entropy, Gibbs free energy, Maxwell's relations, TS diagram 73 mechanical properties of matter, stress, strain, Hooke's law, elastic constants and their relations, torsional pendulum, cantilever, stress-strain diagrams, crystallography, lattice, basis and crystal structure, unit cell, crystal systems, number of atoms per unit cell, coordination number, packing fraction for cubic lattice, lattice planes, Miller indices, relation between interplanar distance and Miller indices, X-ray diffraction and Bragg's law. Textbook 1. Engineering Physics, B.K. Pandey and S. Chaturvedi, Cengage Publication, New Delhi, 2013, 2. Concepts of Modern Physics, A. Beiser, Todd McGraw-Hill Publication, 2007. Reference Book 1. Engineering Physics, Gar and S. C. Gupta, Danpit Rai Publications, New Delhi, 2003, 2. Engineering Physics, Dutta R. Joshi, Todd McGraw-Hill Publication, 2010, 3. Quantum Mechanics, L.I. Schiff, Todd McGraw-Hill Publication, 2010, 4. Introduction to Solid-State Physics, C. Kittle, Wiley India PVT Limited 7 edition, 2007, 5. Elements of Properties of Matter, D.S. Mathur, 11th edition, S. Chand and Company, New Delhi. Next Chemistry, Chemical Bonding, MO Theory to explain bonding in homo and heteronuclear diatomic molecules, Band Theory, band diagrams for conductor, insulator, and semiconductors, bonding in complexes, VBT CFT, application of CFT in explaining magnetic moment and color of complexes, chemical equilibrium and thermodynamics, internal energy, enthalpy, entropy, and free energy, dependence of free energy on temperature and pressure, Gibbs-Helmholtz equation, conditions of spontaneity and equilibrium, equilibrium constants Kp and Kc, free energy change and equilibrium constants, Le Chatelier's principle and its applications to industrial syntheses, Van Hoff isotherm and Clapeyron-Clausius equation, partial molar properties, chemical potential, Gibbs-Duhem equation, 74. Electrochemistry, conductance, effect of concentration, ionic mobilities, Kohlrausch's law and application, transport number, determination by Hittorff's method, types of electrodes, electrode cell potential, Nernst equation and applications, to find electrode cell potential, equilibrium constant, solubility product and pH, modern batteries, fuel cells, AFCs, PEMFs, SOFCs, MCFCs, Zener battery, Li-ion battery, NiM-H battery, corrosion mechanism, of dry and wet corrosion, types of wet corrosion, prevention, chemical kinetics, rate of the reaction and rate laws of multi-step reactions, steady-state approximation, parallel, opposing and consecutive reactions, theory of reaction, collision theory, Lindemann's modification and absolute reaction theory, catalysis, types, theories, kinetics of enzyme catalysis, Micheli's-Menten mechanism, spectroscopy, UV-vis spectroscopy, Beer-Lambert's law, types of transition, concept of oxychrome and chromophore, factors affecting and Woodward-Fieser rules for calculation of endiene systems, IR spectroscopy, types of vibration, Hooke's law, detection of functional groups like CC, C equals C, O and H2 and C equals O. Textbook 1. Engineering Chemistry, Jane and Jane, 16th edition, Danpit Rai Publishing Company 2. Elementary Organic Spectroscopy, Y.R. Sharma, Revised Edition, 4th edition, S. Chand Group. Reference Book 1, Advanced in Organic Chemistry, Satya Prakash, G.D. Tooley, R.D. Madden, 2012, S. Chand Group 2. Principles of Physical Chemistry, B.R. Puri, L.R. Sharma, M.S. Pathania, 42 edition, 2007, Vishal Publishing Company 3. Elements of Physical Chemistry, Samuel Gladstone, 2nd edition, Macmillan 4. Spectrometric Identification of Organic Compounds, R.M. Silverstein, F.X. Webster, D. Kiemel, 7th edition, 2005. Wiley, Chapter 1005 Environmental Science CR2. Course outcome. At the end of the course, the students will be able to CO1. Understand different components and composition of environment and importance of EI. CO2. Understand different air pollutants and their controlling measures, some important global phenomena. CO3. Understand different water pollutants, sewage treatment, estimate different water quality parameters. CO4. Understand different principles of green chemistry, our 4M4 principle, cradle-to-grave approach. CO5. Identify biochemical effects of toxic wastes, different steps in solid waste management. Prerequisite. NIL. Overview. Overview on environment, terminologies, components of Earth, lithosphere, atmosphere, and biosphere, concept of black body radiation, and albedo. Importance, scope and principles of EIA. 75. Air pollution. Primary and secondary air pollutants, smog, oxidizing and reducing, important environmental issues, ozone layer depletion, acid rain, greenhouse effect, controlling measures, electrostatic precipitator, cyclone separator, catalytic converter, scrubbing, water pollution, types and sources of water pollutants, sewage treatment, primary, secondary and tertiary treatments, acid-base chemistry, pH and buffer, analysis of water quality parameters like dew, BOD, alkalinity, hardness, chloride, fluoride, USIPA and WHO guidelines for drinking water, green chemistry, basic principles of green chemistry with examples, matrices to explain greenness, R to the power of 4M to the power of 4 model with specific reference to ecnoburet, life cycle analysis, cradle-to-grave approach, waste management, classification of solid wastes, toxic and biochemical effects of solid wastes, heavy metals, biomedical and radioactive wastes, sources, and generation, management of solid wastes, collection, segregation, disposal. Textbook 1. Environmental Chemistry, AKDA, 7th edition, New Age International Publishers, Reference Book 1, Fundamentals of Environment and Ecology, DIDA, 2013 S. Chand Group 2, Engineering Chemistry, Jane and Jane, 16th edition, Danpit Rai Publishing Company 3, Environmental Science and Engineering, Aloka Debbie, 2nd edition, Universities Press 4, Textbook of Environmental Studies for Undergraduate Courses, Arach Baracha, 2nd edition, Universities Press 5, A Textbook of Environmental Studies, Sashi Chawla, 2012, McGraw-Hill. Next, Mathematics, Ordinary Differential Equations, Basic Concepts and Definitions of One-Order Differential Equations, Formation of Differential Equations, Solution of Differential Equations, Variable Separable, Homogeneous, Equations Reducible to Homogeneous Form, Exact Differential Equation, Equations Reducible to Exact Form, Linear Differential Equation, Equations Reducible to Linear Form, Bernoulli's Equation, Orthogonal Trajectories, Applications of Differential Equations, Linear Differential Equations of 2 and higher order, second-order linear homogeneous equations with constant coefficients, differential operators, solution of homogeneous equations, Euler-Cauchy equation, linear dependence and independence, Wronskian, solution of non-homogeneous equations, general solution, complementary function, particular integral, solution by variation of parameters, undetermined coefficients, higher order linear homogeneous equations, applications, differential calculus 2 and 3 variables, Taylor's theorem, maxima and minima, Lagrange's multipliers, matrices, determinants, linear system of equations, basic concepts of algebra of matrices, types of matrices, vector space, subspace, basis, and dimension, linear system of equations, consistency of linear systems, rank of matrix, Gauss elimination, inverse of a matrix by Gauss-Jordan method, linear dependence and independence, linear transformation, inverse transformation, applications of matrices, determinants, Kramer's rule, matrix eigenvalue problems, eigenvalues, eigenvectors, Cayley-Hamilton theorem, basis, complex matrices, quadratic form, Hermitian, skew-Hermitian forms, similar matrices, diagonalization of matrices, transformation of forms to principal axis, conic section, textbook 1. Krisigi, Advanced Engineering Mathematics, Wiley, 9 edition 2, Shanti Narayan and P.K. Middle, Differential Calculus S. Chand, reprint 2009. References Book 1. Graywall B.S., Higher Engineering Mathematics, Kana Publishers, 36 edition 2. Das H.K., Introduction to Engineering Mathematics, S. Chand, and Company Limited, 11 edition 3. Ramana B.V., Higher Engineering Mathematics, TMH, 1st edition 4. J. Sinha Roy, and S. Padhi, A Course on Ordinary and Partial Differential Equation, Kalyani Publication, 3rd edition. Next, Mathematics to Laplace Transforms. Laplace transform, inverse Laplace transform, linearity, transform of derivatives and integrals, unit step function, Dirac delta function, second shifting theorem, differentiation and integration of transforms, convolution, integral equation, application to solve differential and integral equations, systems of differential equations, series solution of differential equations, power series, radius of convergence, power series, method, Frobenius method, special functions, gamma function, beta function, Legendre's and Bessel's equations, Legendre's function, Bessel's function, orthogonal functions, generating functions, Fourier series, integrals and transforms, periodic functions, even and odd functions, Fourier series, half-range expansion, Fourier integrals, Fourier sine and cosine transforms, Fourier transform, vector differential calculus, vector and scalar functions and fields, derivatives, gradient of a scalar field, directional derivative, divergence of a vector field, curl of a vector field, vector integral calculus, line integral, double integral, Green's theorem, surface integral, triple integral, divergence theorem for Gauss, Stokes theorem, textbook 1, Kriesige, Advanced Engineering Mathematics, Wiley, 9 edition, reference book 1, Graywall B.S., Higher Engineering Mathematics, Kana Publishers, 36 edition 2, Das H.K., Introduction to Engineering Mathematics, S. Chand and Company Limited, 11 edition 3, Ramana B.V., Higher Engineering Mathematics, TMH, IST edition 4, J. Sinha Roy and S. Padhi, A Course on Ordinary and Partial Differential Equation, Kalyani Publication, 3 edition, Mathematics 3, Partial Differential Equations, Basic Concepts, Solution of PDE by Variable Separable Method, Mathematical Modeling of One-Dimensional Wave Equation and its Solution, Classification of PDE, and transformation into its normal form, D'Alembert solution of wave equation, solution of one-dimensional heat equation, steady-state flow of heat in a rectangular bar, solution of one-dimensional heat equation by Fourier integral, solution of two-dimensional wave equation, Laplace equation in polar, cylindrical and spherical coordinates and applications, solution of PDE by use of Laplace transform, complex analysis, complex numbers and functions, basic concept, complex functions, derivatives, analyticity, Cauchy-Riemann equations, exponential, trigonometric, hyperbolic, logarithmic functions, general powers, complex integration, line integral of independent path, Cauchy's integral theorem, Cauchy's integral formula, derivatives of analytic function, Taylor series, Maclaurin series, Laurent series, expansion of functions, singularities, residues, residue integration method, evaluation of real integrals, mapping, conformal mapping and linear fractional transformation LFT, Textbook 1, Advanced Engineering Mathematics by Erwin Kriesig, Wiley, Incorporated, 9 edition, Reference Book 1, Higher Engineering Mathematics by B.V. Ramana, TMH, 2007, Mathematics IV Approximations and Errors, Approximation of Numbers by Truncation and Rounding Off, Types of Errors, Numerical Solution of Nonlinear Equations, Solutions by Bisection Method, Fixed Point Iteration Method, Newton-Raphson Method, Regula-Falsy, and Secant Method, Rate of convergence of secant, and Newton-Raphson method, interpolation and approximation, finite differences, operators and relation between them, interpolation, Newton's forward and backward difference interpolation, Newton's divided difference interpolation, and Lagrange interpolation, approximation of functions by best fit straight line, quadratic, and exponential curves using least square method, numerical differentiation and integration, numerical differentiation of 1 and 2 order using difference table, trapezoidal rule, Simpson's 1/3 and 3/8 rules, Gauss-Legendre's 2 points and 3 points formulae, error in numerical integration, numerical solution to ODE, Taylor series method, Euler's method, modified Euler's method, Runge-Kutta methods of order 2 and 4, reduction of 2-order ODE to first-order ODE and its solution by RK method of order 4, solution of system of linear equations, LU factorization Kraut, Doolittle and Cholesky, solutions by Gauss-Seidel and Gauss-Jacobi methods, largest eigenvalue and corresponding eigenvector by power method, probability theory, introduction to probability, random variables and probability distributions, mean and variance of probability distributions, mathematical expectation, moments and moment generating function, binomial and Poisson distributions, normal distribution. 80. Textbook 1. Advanced Engineering Mathematics by Erwin Kriesig, Wiley, Incorporated, 9 edition. Reference book 1. Higher Engineering Mathematics by B.V. Ramana, TMH, 2007. 2. Higher Engineering Mathematics by B.S. Graywall, Kana Publisher, 36 edition. 3. Numerical Methods for Scientific and Engineering Computation by Jane Iyer and Jane, New Age International, P. Limited. 6th edition. 4. Numerical Methods by Arumugam, Thangapandi and Somasundaram, Sidech Publishers, 2 edition. Discrete Mathematical Structure, Logic, Proposition, Truth Values, Connectives, Logical Equivalence of Composite Statement using Truth Table and without Truth Table, Predicates and Quantifiers, Rules of Inference, Methods of Induction, Set, Relation and Function, Set, Operations on Set, Principles of Inclusion and Exclusion, Relation, Types of Relations, Properties on Binary Relation, Equivalence Relation, Partial Ordering Relation, Hasse Diagram, Lattice, Definition of Function, Injection, Bijection, Surjection, Permutation Function, 81. Boolean Algebra, Lattices and Algebraic System, Principles of Duality Law, Basic Properties, Boolean Function, and Boolean Expressions, DNF and CNF, Recurrence Relation and their solutions, Discrete Numeric Function and their manipulation, Generating Function, Concept of Recurrence Relation with Constant Coefficients, Solution of Recurrence Relation, Direct Method and by using Generating Function, Graph Theory, Basic Terminology, Types of Graphs, Group Code, Isomorphic Test, Adjacency and Incident Matrix, Paths, Circuit, Shortest Path Algorithms, Dijkstra, Tree, Rooted Tree, Binary Tree, Spanning Tree, Cut Set, MSD Algorithms, Prim, and Kruskal, Planar Graph, Groups and Rings, Concept of Binary Operations, Algebraic Structures, Semigroup, Monad, Group, Abelian Group with Examples, Properties of Groups, Cyclic Groups, and its Generator, Subgroup, Normal Subgroup, Cosets, Lagrange's Theorem, Homomorphism and Isomorphism, Ring, Field, Integral Domain Definition with Examples, Textbook 1, Discrete Mathematical Structure, PHI by Kalman, Busby, and Ross. Reference Book 1, Elements of Discrete Mathematics, a Computer-Oriented Approach by C. L. Liu, D.P. Mahapatra Tata McGraw-Hill 4th edition 2013. 2. Discrete Mathematics, and its Applications by Kenneth H. Rosen, Tata McGraw-Hill 4th edition. Numerical Methods, Approximations and Errors, Approximation of Numbers by Truncation and Rounding Off, Types of Errors. 82. Numerical Solution of Nonlinear Equations, Solutions by Bisection Method, Fixed Point Iteration Method, Newton-Raphson Method, Regular-Falsy, and Secant Method, Rate of Convergence of Secant, and Newton-Raphson Method, Interpolation and Approximation, Finite Differences, Operators and Relation between them, Interpolation, Newton's Forward and Backward Difference Interpolation, Newton's Divided Difference Interpolation, and Lagrange Interpolation, Numerical Differentiation and Integration, Numerical Differentiation of 1 and 2 order using Difference Table, Trapezoidal Rule, Simpson's 1/3 and 3/8 rules, Gauss-Legendre's 2 points and 3 points formulae, Error in Numerical Integration, Numerical Solution to O. Taylor Series Method, Euler's Method, Modified Euler's Method, Runge-Kutta Methods of Order 2 and 4, Reduction of 2-order ode to first-order ode and its solution by RK Method of Order 4, Solution of System of Linear Equations, Solutions by Gauss-Seidel and Gauss-Jacobi Methods, Numerical Solution to PD, Types of Partial Differential Equations, Finite Difference Approximations of Derivatives, Numerical Solution of Laplace Equation by 5-point Formula, Numerical Solution of Parabolic Equations by Schmidt Method and Crank-Nicolson Method, Probability Theory, Introduction to Probability, Random Variables and Probability Distributions, Mean and Variance of Probability Distributions, Mathematical Expectation, Moments and Moment Generating Function, Binomial and Poisson Distributions, Normal Distribution, Textbook 1, Advanced Engineering Mathematics by Irwin Krestig, Wiley 9th edition, Reference Book 1, Higher Engineering Mathematics by B.V. Ramana, TMH, 2007. 2. Higher Engineering Mathematics by B.S. Graywall, Kana Publisher, 36 edition. 3. Numerical Methods for Scientific and Engineering Computation by Jane Iyer and Jane, New Age International, P. Limited, 6 Edict Ion 4. Numerical Methods by Arumugam, Thangapandi, and Somasundaram, Sidech Publishers, 2 edition. Next subject come Humanities. Now I will explain in short. You can pause the video and read it. Professional Communication Engineering, Economics, International Economics, Professional Ethics, and Code of Conduct, Human Resource Management, Entrepreneurship, Law of Contracts, and Law of Torts, Intellectual Property Law. Now next come to our main topic, mechanical engineering, engineering mechanics, course outcome. At the end of the course, the students will be able to CO1. Identify and formulate elementary level engineering problems related to particle mechanics, in conceptual form as well as in terms of mathematical and physical models, and to solve problems dealing with forces in a plane or in space, and equivalent force systems. CO2. Solve real-life problems by using mathematics, physical laws, and theorems. CO3. Utilize scalar and vector analytical techniques for analyzing forces in statically determinate structures, and to analyze and design a bridge in a safe and economical way using the knowledge gained from trusses and frames. CO4. Apply the basic principles of energy methods to the analysis of particles subjected to forces. CO5. Apply fundamental concepts of kinematics and kinetics of particles to the analysis of simple, practical problems. Prerequisite. Nil. Concurrent forces in a plane. Introduction to engineering mechanics, free body diagrams, composition and resolution of forces, equilibrium of concurrent forces in a plane, methods of projections, methods of moments, friction, static friction, laws of dry friction, applied of friction in inclined plane, wedge friction, belt friction, parallel forces in a plane, parallel forces acting in the same and opposite directions, general case of parallel forces in a plane, center of parallel forces, centroid and center of gravity, theorem of Pappus, center of composite plane figures and curves, distributed forces in a plane, moment of inertia, MI of plane figures, parallel axis theorem, perpendicular axis theorem, and MI of composite figures, force analysis of plane trusses and frames, methods of joints, method of sections and method of members, principle of virtual work, equilibrium of ideal systems, virtual work, kinematics of rectilinear motion, differential equations of rectilinear motion, force proportional to displacement, free vibration, D'Alembert's principle, momentum and impulse, work and energy, conservation of energy, impact, kinematics of curvilinear motion, normal and tangential acceleration, motion of a projectile, work and energy in curvilinear motion, rotation of a rigid body, kinematic S of rotation, rotation under the action of a constant moment. Textbook 1. Engineering Mechanics S. Timoshenko, D.H. Young and J.V. Rauti M.H. 372. 32 Reference Book 1. Engineering Mechanics, Statics and Dynamics. Baer and Johnson, TMH 2. Engineering Mechanics S.S. Bavacati, New Age International, Course Outcome. At the end of the course, the students will be able to CO1. Comprehend terminology related to thermal engineering. CO2. Recognize the need of learning thermodynamics. CO3. Appreciate the first law in cyclic and acyclic processes. CO4. Interpret the second law in applications related to heat engine, heat pump, and refrigerators. CO5. Read and comprehend steam table and Molar chart in solving complex thermal problems. CO6. Compute availability. Prerequisite. Mathematics IMA 1001. Basic concepts and definitions. Scope of thermodynamics, macroscopic and microscopic approaches, definition of fixed mass, closed system, and control volume open system, properties, extensive and intensive, state and representation on a property diagram, process, and its representation, cyclic process, or cycle, and its representation, characteristics of properties, point and path function, reversible and irreversible processes, thermal, mechanical, and chemical equilibrium, thermodynamic equilibrium, zeroth law of thermodynamics, forms of energy, energy transfer by heat, forms of work, electrical and mechanical energy transfer by work, conservation of mass in a control volume, first law of thermodynamics, moving boundary work, PDV work for different processes, first law for closed systems, for cyclic and non-cyclic processes, introduction of internal energy as a thermodynamic property, flow work and energy of a flowing fluid, first law for control volumes open systems, and introduction of enthalpy as a thermodynamic property, application of first law to different processes of fixed masses, closed systems, and control volumes. Second law of thermodynamics, Kelvin-Planck and Clausius statements of second law, reversible and irreversible processes, irreversibilities, Carnot principles, Clausius inequality, definition of entropy, and its evaluation for various processes of pure substances, principle of increase of entropy, entropy generation, pure substances, definition of pure substance, PV and TV diagrams for pure substances, specific volumes of saturated liquid, wet vapor, and superheated vapor, use of steam tables in finding internal energy and enthalpy of steam at different conditions, thermodynamic property relations, ideal gases and their PVT relation, the Maxwell relations, the Clapeyron's equation, change in internal energy, change in internal enthalpy, the T. D's relation between specific heats, isothermal compressibility, and volume expansivity, the Joule-Thomson coefficient, exergy, available energy or exergy, useful work, availability for closed systems, flow availability, reversibility, second law efficiency, textbook, 1, Thermodynamics and Engineering Approach, Eunice A. Sengel and Michael A. Bowles, McGraw-Hill Education, 7th edition, 2011, reprint 2013. Now I will explain in short. You can pause the video and read it. Machine dynamics, fluid mechanics, material science and engineering, fluid dynamics and hydraulic machines, kinematic and kinetics of machines, basic manufacturing processes, thermodynamics and hydraulics, kinematics and dynamics of machines, manufacturing technology, thermodynamics and fluid mechanics, mechanics of solids, solid mechanics and machine design, internal combustion engines and gas turbines, fundamentals of machine design, heat transfer, design of machine elements, refrigeration and air conditioning, manufacturing processes and design, advanced manufacturing processes, principles of turbomachines, mechanical vibration and noise engineering, mechatronics, supply chain management, computer-controlled manufacturing system, total quality management, fundamentals of computational fluid dynamics, total quality management and reliability engineering, boundary layer theory, advanced mechanics of solids, robotics, fluid power engineering and control, biomechanics, solar energy systems, mechatronic systems, production and operations management, finite element method for engineers, mechanics of composite materials, mechanical measurements and control, tribology, metal forming processes, alternative fuels and renewable energy, industrial safety, computer integrated manufacturing, automobile engineering, computational fluid dynamics, machine tools technology, advanced operations research, additive manufacturing. Hello guys, I am a college student now and I suffered from an incident, so at present I can't paying my high college fees, so if you people can help me by donate some money to complete my study, then it will be a great help from you. Thank you for watching our videos. To get more videos like that, please subscribe our channel and like and share.